When multiple loads are connected in parallel, the total current, measured in amps, drawn from the power source is the sum of the currents drawn by each individual load. Changing the voltage taps from 400 volts to 208 volts will result in a higher amperage draw for the same wattage. This is because the lower voltage requires more current to deliver the same amount of power. Firstly, at 400 volts, each 400 watt lamp draws 11 amps. If there are 3 lamps, the total current draw is 11 amps times 3, which equals 33 amps. Secondly, at 208 volts, each 400 watt lamp now draws 6.8 amps. If 2 lamps are connected in the same phase, the total current draw for those 2 lamps is 6.8 amps times 2, which equals 13.6 amps. To determine the total amps required, consider the phase connections. If the 2 lamps are connected on different phases, the total amps drawn from the power source is the sum of the individual phase currents. Therefore, if the lamps are on different phases, the calculation is 13.6 amps plus 13.6 amps, which equals 27.2 amps. However, if the 2 lamps are connected on the same phase, the total amps drawn from the power source is simply the total current drawn by the 2 lamps on that phase, which is 13.6 amps. To summarize, if the 2 400 watt lamps are connected on different phases, the total amperage required at 208 volts is 27.2 amps. If the 2 400 watt lamps are connected in the same phase, the total amperage required at 208 volts is 13.6 amps. Understanding the relationship between voltage, amperage, and wattage is crucial in electrical calculations. Ohm's law and the power formula are fundamental concepts. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. The power formula states that power equals voltage times current, or watts equals volts times amps. Rearranging the power formula, you can solve for current by dividing power by voltage. In this example, each lamp consumes 400 watts of power. At 400 volts, the current is 400 watts divided by 400 volts, which equals 1 amp. The question stated 11 amps, which may imply that the power factor of the lamp is not 1. However, at 208 volts, the current is 400 watts divided by 208 volts, which equals approximately 1.92 amps. However, the question states that it draws 6.8 amps. Again, this may imply that the power factor of the lamp is not 1. When dealing with 3-phase power systems, the calculations can become more complex. In a balanced 3-phase system, the power is distributed equally across the 3 phases. However, if the load is unbalanced, the current in each phase may be different. To calculate the total current in a 3-phase system, you need to consider the phase angle between the currents in each phase. The formula for calculating the total current in a balanced 3-phase system is the square root of 3 times the line voltage times the line current times the power factor. When working with electrical circuits, it's important to follow all safety precautions. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as safety glasses and gloves. If you're not comfortable working with electricity, consult a qualified electrician. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It's important to be familiar with the NEC if you're working with electricity. Article 210 of the NEC covers branch circuits, which are the circuits that supply power to outlets and lighting fixtures. Article 215 of the NEC covers feeders, which are the circuits that supply power to branch circuits. Article 220 of the NEC covers the calculation of branch circuit, feeder, and service loads. These calculations are used to determine the size of the conductors and overcurrent protection devices needed for an electrical installation. When calculating the load for lighting, the NEC requires you to use a certain amount of volt-amps per square foot, depending on the type of occupancy. For example, for dwelling units, the NEC requires 3 volt-amps per square foot. For commercial buildings, the NEC requires a different amount of volt-amps per square foot, depending on the type of occupancy. The NEC also requires you to consider any specific loads, such as motors, appliances, and HVAC equipment. These loads must be added to the general lighting load to determine the total load. When sizing conductors, the NEC requires you to use the ampacity tables in Article 310. These tables provide the allowable ampacity for different types of conductors based on their size, insulation, and temperature rating. The NEC also requires you to direct the ampacity of conductors if they are installed in certain conditions, such as in raceways or bundles. When selecting overcurrent protection devices, the NEC requires you to use devices that are rated to protect the conductors they are protecting. The overcurrent protection device should have a trip rating that is no greater than the ampacity of the conductor. The NEC also requires you to consider the interrupting rating of the overcurrent protection device. The interrupting rating is the maximum amount of current that the device can safely interrupt. When grounding and bonding electrical systems, the NEC requires you to connect all non-current carrying metal parts to ground. This helps to protect people from electric shock in the event of a fault. The NEC also requires you to bond together all metal parts that are likely to become energized, such as metal water pipes and metal building frames. Understanding these basic electrical concepts and following the NEC guidelines will help ensure safe and reliable electrical installations. Remember, working with electricity can be dangerous, so always take precautions and consult a qualified electrician if you have any questions. Firstly, it is essential to understand the relationship between power, voltage, and current in electrical circuits. Power, measured in watts, is the rate at which electrical energy is transferred. Voltage, measured in volts, is the electrical potential difference that drives the current through a circuit. Current, measured in amps, is the flow of electrical charge. These three quantities are related by the formula power equals voltage times current, or watts equals volts times amps. Secondly, when the voltage is changed, the current will also change if the power remains constant. This is because the power is equal to the voltage times the current. If the voltage is decreased, the current must increase to maintain the same power. Conversely, if the voltage is increased, the current must decrease to maintain the same power. Thirdly, in the context of the question, the total amperage depends on how the lamps are connected. If the lamps are connected in parallel on the same phase, the total amperage is the sum of the individual amperages. However, if the lamps are connected to different phases, the calculation becomes more complex and depends on the phase angle between the currents. In a balanced three-phase system, the current are 120 degrees out of phase, and the total current can be calculated using vector addition. Fourthly, for safety and code compliance, it is crucial to consult the NEC. The NEC provides guidelines for calculating electrical loads, selecting conductors, and installing overcurrent protection devices. The NEC also specifies the requirements for grounding and bonding electrical systems. Fifthly, when working with electrical circuits, always disconnect the power before making any connections or modifications. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, consult a qualified electrician. The NEC specifies requirements for conductor ampacity, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. Conductor ampacity is affected by several factors, including the size and type of conductor, the insulation material, and the ambient temperature. The NEC provides tables that list the ampacity of different types of conductors under various conditions. When selecting conductors for an electrical circuit, it is important to choose conductors that have an ampacity that is sufficient to carry the load current. It is also important to consider the voltage drop in the circuit. Voltage drop is the decrease in voltage that occurs as current flows through a conductor. Excessive voltage drop can cause equipment to malfunction or overheat. The NEC provides guidelines for limiting voltage drop in electrical circuits. The NEC specifies requirements for overcurrent protection, which is the use of devices such as fuses and circuit breakers to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of current when the current exceeds a safe level. This prevents damage to the electrical system and reduces the risk of fire. The NEC specifies the maximum size of overcurrent protection devices that can be used for different types of circuits. The NEC specifies requirements for grounding and bonding, which are the connection of electrical equipment and systems to the earth. Grounding and bonding help to protect people from electric shock and reduce the risk of fire. Grounding provides a low impedance path for fault current to flow back to the source, which causes the overcurrent protection device to trip and to energize the circuit. Bonding connects all metal parts of an electrical system together, which helps to equalize the voltage potential and prevent electric shock. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding jumpers. In summary, understanding the relationships between power, voltage, and current following the NEC guidelines and taking safety precautions are essential for working with electrical circuits. The National Electrical Code, specifically Articles 210.19, A1, 215.2, A1, and 220.3 provides guidance on branch circuit and feeder sizing.